So are you able to see this?
Yes, sir.
So we got matrix A and B matrix. So B matrix mein we have added all the diffusion terms, and A matrix is the nothing but in your the left hand side one, the DC one upon the DT term, and C matrix is your all boundaries. Okay. So now we want to evaluate this, because everywhere you have to integrate this 0 to L and again 0 to L. So we want to integrate this, and let's see how can we integrate this for entire our boundary actually. Fine.
Yes, sir.
So let's see what to do. So what you have there. So this I will just leave it here. So what you have here is just like that. This is your entire boundary. This is your 0. Let's say you can take it, this z equal to 0 means bottom one. This is at z equal to L, you have at top one, right? Fine. Or
Yes.
you can interchange that. You can consider this at top, this at the bottom. This is the choice is completely yours. It won't create any problem. Fine. So the entire thing has been the divided into several elements for each of the means understanding. For time being, I have just considered two elements. One element here of the length L1, other element is there from L1 to L only. Okay.
Yes, sir.
Yes, sir.
Now in each of the element there is a midpoint that's called here. This is half of the element size. This is L1 by 2. Same thing here. Whatever the length is present of the element 2 is this is there, the half of this here at this particular point. Okay. Now we want to take the basis function. So basis function could be just linear, could be quadratic, and could be cubic in the nature. So cubic one is further complicated. So we for quadratic one also works well without much problem. So we have taken the quadratic basis function. Means quadratic means it should have power 2 terms actually. That's what is called quadratic one. Fine. So now this basis function, this phi are chosen in the such a way that it has the value 1 at one of the node, and it have value 0 at other two node. Means let's say phi 1. Phi 1 has value 1 at node 0. This one first node. It have the 0 values at node 2 and node 3. Okay, so it has just value 1 at one of the nodes. So one of the nodes means at node 1 its value is 1. At other two nodes its value is 0. Okay.
Yes, sir.
Same thing is being taken psi 2. Psi 2 is being taken in the such a way because first node is completed because it has value 1 here. Now we were talking about the node 2. So node 2 may we want to have a basis function. It's have actually value 1 here, and rest of the two nodes here, first node 1 and node 3, it have value 0. Okay.
Yes, sir.
Now we have come to node number 3. So we want a basis function here such that it should have a value 1 here. So that is here phi 3. It's have value 1 here. And rest of the nodes, node number 2 and node number 1, it has the value 0. Okay.
Yes, sir.
So we have 3 nodes and 3 basis function. Is that fine? And each basis function have value 1 at one of the nodes, and rest of the nodes this have value 0.
Yes, sir.
Now go to the element 2. So element 2, again you want to take the same thing, that you want to have a phi 1 here. You want to have, this is phi 4 is the nothing but is your phi 2, and your phi 5 is the nothing but your phi 3 type of thing here. This phi 3, right?
Yes, sir.
Okay. So that's one thing. It's just whatever you have in the element 1, same thing is being pasted for element 2, element 3, element 4, 5, 6, and like that. Just keep on pasting, right? That way. Fine. That's first part. Hello?
Yes, sir. Yes, sir.
So if you have taken this first element 5, 1, 5, 2, 5, 3, so from here also you can take this 4, 5, 6. If a person wants to get confused, okay, so I can take this side, this one is 4, this one is 5, this one is the 6. But this I have taken because this have also some significance. Now, if you will take from, see the figure here, further part here. So this you see the phi 3. So phi 3 is getting extended from here to here. And now it's going extended from element 2 also, because this look like a one sort of function. If first it went of the something like that, then again it went to the something like that. So it means that your phi 3 is getting expanded into two elements, element number 1, then element number 2. However, in rest of the case, let's say this phi 2 is not getting extended in phi means the element 2, because if we say this shape is here, so if it want to extend here, it should go to the something like that, but it's not happening, right?
Yes, sir.
Same thing for this phi 1. So phi 1 here, it the look like of this shape. Now, if it want to extend in the element 2, so it should look like of actually similar to this only. So it should go something like that, and it should go something like that. So it's not going that way also, right? So phi 1 is not also extending to the element 2. Phi 2 is also not extending to element 2. Only phi 3 is getting extended into element number 2. You can see from the shape also, right? This way. It's just look like a continuous function, right?
Yes, sir.
Now, let's go further. Now, these are the derivation of this phi 1, phi 2, phi 3. You can also do the derivation of this. You can, because we have considered quadratic basis function. So you can consider, let's say phi 1 is ax square plus bx plus c. That's it called your quadratic equation, right?
Yes, sir.
Correct. Now you can take your boundary condition, or the for this you have, let's say at x equal to 0, your function phi is 1. X equal to L1 by 2, your phi 1 is the 0. X equal to L1, your phi 1 is again 0. So you have three boundaries, three unknowns. So you can calculate constant ABC.
Yes, sir.
So that's what I did here. So I did here, this is actually, this I did for element is getting changed from A to B. Means this point is A, this point is B. So you can easily change to A के जगह आप put कर सकते हैं 0, and at the place of B you can put L1, because here it's getting changed from 0 to L1. So in place of the 0 to L1, I just taken here A to B. So A is the 0 and B is L1 only. So if your element size is A to B, so these would be equation for your phi 1, phi 2, phi 3. The derivation can be done, or these are also the given in any of the mathematics, the book also. Fine.
Yes, sir.
Okay, sir.
Now further, you can change here. I wrote here also, so you can change A to 0b to L1, so you will get 5 1 5 2 5 3 in element number 1. Same thing you can change for element number 2. As element number 2 में आपका a क्या हो जाएगा? A is L1 and your b is capital L, right? So you can change these functions for any of the elements, just putting the value of a and b. Okay? Hello?
Yes, sir.
Yes, sir.
Now, so in that case, if you want to change it for the 0 to L1, so your equation would become something like this. This would be the equation of phi 1. This would be equation of phi 2. This would be the equation of phi 3. Same thing, you can change from L1 to L. So your A would become L1, your B would become capital L. So these would be your equation for phi 3, phi 4, phi 5 in equation means element number 2.
Excuse me, sir.
Yeah.
Sir, in the first element, A is 0 and B is L.
L1.
L1, yes, sir. So, but in the 46 equation, we have written B, sir. That's why 3B.
Okay, so B need to be changed then. So maybe my mistake here. So that that you can check. You can check here because A would become the 0 here. A will the went away here. It will become here 3L1 and it would become L1 square. So
Yes, sir.
what I wrote here.
3L
So
will come,
this will
sir.
become
3L1.
yeah, so 3L1 would become here. So it will become practically 3/L1, right?
Yes, sir.
Right. So that is my mistake. So you can check it. Fine. Now these are your basis functions. You have changed now 0 to L1. Correct? Now let's see further. What power the matrix are? Matrix are these, right? This is let's say we want to evaluate first for matrix number A. So A में क्या है? You have 0 to L1 phi 1 phi 1. Then here 0 to L1 phi 2 phi 1. 0 to L phi 3 phi 1. So you have here n number of the point till phi n phi 1. This one phi is just for psi. Second वाला जो phi है is just for psi. So in first row your psi is 1, second your psi is 2 and keep on going. So you want to evaluate, let's say element number 1, दिए पहला term you want to evaluate. Okay? Hello?
Yes, sir.
Yes, sir.
Now this we want to add phi 1 phi 1 you want to evaluate from 0 to L. So I can write the 0 to L into two parts. One is from 0 to L1 and next is from L1 to L, right? Because
Yes,
sir.
I just bifurcated entire boundary into two elements. One is 0 to L1, next is from L1 to L.
Yes,
So
sir.
I can write this one. So this is your element number 1. So you have here A11 is this one only. So I wrote for this A11 0 to L phi 1 phi 1, right? Now this I can change into two parts. One is from 0 to L1 and the another one is from L1 to L. Is that fine till here?
Yes, sir.
Yes, sir.
Now this is 0 to L1 is my element number 1 and L1 to L is my element number 2. Correct?
Yes, sir.
Now element number 2 में do you have phi 1? Let's see here.
No, sir.
Element number 2 में आपका phi 1 है नहीं. Phi 1 is present only in element number 1. एलिमेंट नंबर 2 में आपका phi 1 है नहीं बिकॉज ये phi 1 यहाँ पे जा नहीं रहा है. फाइन.
Yes, sir.
Therefore आपका जो this element is the next component here, this L1 to L phi 1 is getting 0. So you got only first term 0 to L1 5 1 5 1. This is for element number 1 of matrix A11. Same way you can calculate A12. A12 is again same 0 to L 5 to 5 1. This again you have the bifurcated into two parts 0 to L1 and again L1 to L. Correct?
Yes, sir.
Yes, sir.
Now phi 2 is also not getting extended into element number 2. So therefore this second term is getting cancelled. So you got only first term 0 to L1 5 to 5 1. Okay.
Yes, sir.
Yes, sir.
Now you just see the element number 3. You will get here 5 3 5 1. So you wrote again for the element number 1, element number 2. अब यहाँ पे your phi 3 is getting extended, but phi 1 is not getting extended, right? So phi 3 है वहाँ पे, phi 1 is not there. Therefore, this product would become 0. Second term का product would become 0. Okay?
Yes, sir.
So therefore, you got only first term 0 to L1 phi 3 phi 1. Now, if you want to calculate, let's say A14. So A14 में क्या आएगा आपके पास में? You will get here 5 4 5 1, right?
Yes,
This
sir.
one. Now you can write again in 2 points 5 4 5 1 5 4 5 1. Let's see, is the 5 4 present in the element number 1? It is not. 5 4 is not getting extended into element number 1. Only phi 3 is getting extended into both the elements, correct?
Yes, sir.
So you don't have phi 4 in element number 1. Therefore, first term would become the 0. Second thing here, second term in the element number 2, your phi 4 is present, but phi 1 is not present. So therefore, this product would also would become 0.
Yes, sir.
So both the product would become the 0 because the phi 1 is only present in element number 1. Phi 4 is only present in the element number 2. It's not getting extended in that way. So both the term would become 0 here. Same thing, let's say fifth one, A15. So you have 5 5 5 1. So same thing, your 5 5 is
Sir,
not. Yeah.
can you please repeat, sir? A14.
A14 में आपके पास में you want to evaluate a product of 5 4 5 1, correct? In element
Yes.
number 1, in element number 2. Let's see here. ये आपका एलिमेंट नंबर 1 है. एलिमेंट नंबर 1 में आपका 5 4 है, is not getting extended. You have 5 4 only here. It's not getting extended into element number 1. So you don't have this. So therefore, product of 5 4 5 1 in the element number 1 would be 0.
Yes, sir.
Same thing, element number 2, you have there 5 4, but you don't have 5 5 1 because 5 1 is not getting extended into this way.
Yes, sir.
So therefore, the product of 5 4 5 1 in element number 2 would also become 0.
Yes, I got it, sir.
Correct? Same thing now you do for 5 5 into 5 1. So in the element number 1, you have 5 1, but you don't have 5 5.
Yes, sir.
Same thing here, you have 5 5, but you don't have here 5 1 in the element number 2.
Yes, sir.
Because only phi 3 is getting extended. Rest of these are not getting extended. However, they look like same. They look like a mirror image of the each other, but they are not getting extended. Make sure that phi 2 and phi 4 look like same, but they are not getting means the extended into element to element. That's what I want to say. Okay.
Yes, sir.
So you got element here. So you got all these elements here A1 to 5, and आपने 5 ही एलिमेंट दिया है, वहां पे 5 आर द जहां नोट्स ओनली 2 एलिमेंट्स मीन 5 नोट्स, so your you will have only 5 means entry there, right?
Yes, sir.
सेम थिंग यू कैन डू फॉर सॉल्वेंट नंबर 2, ये आपने दिया है सॉल्वेंट 1 के लिए, सेम थिंग यू कैन कैलकुलेट फॉर द सॉल्वेंट नंबर 2. सॉल्वेंट नंबर 1 हो जाएगा पहले, आफ्टर दैट यू ऐड फॉर सॉल्वेंट नंबर 2, सो यू विल जस्ट ऐड n+1 इन दीज वन ओनली. जो जो अभी आपने पहले कैलकुलेट किया है, जस्ट आपने उसमें n+1 ऐड कर दोगे, सो यू विल गेट योर मैट्रिक्स ए कैलकुलेटेड. ये जो आपका है दिस मैट्रिक्स ए आपका पूरा हो जाएगा. दिस वन, ये फर्स्ट पार्ट इज फॉर द C1, सेकेंड पार्ट इज फॉर योर कंपोनेंट C2. हेलो,
Yes, sir.
Yes, sir.
same thing here, whatever will come on top, same thing would be pasted here up again, because this would be for equation number 2, this would be for equation number 1. So you will get complete your the matrix is 2n by 2n. Okay.
Yes, sir.
Yes, sir.
Now let's say B matrix. अब जो आपका A matrix पाएगा, so you got here 5 1 5 1. You want to evaluate for 0 to L1. Now we know the Gauss quadrature one. Gauss quadrature is valid only from -1 to 1. Correct or not?
Yes, sir.
So we have changed the limits from 0 to L1 to -1 to 1, and this you got a factor here, and these are your basis function now from this a new type here. So this new type is just from -1 to 1. Previous one was there from 0 to L1, right? And your dz is being changed to x here, so x is now between now -1 to 1. And once you will change the limits there, you will get these would be your new psi functions, x square minus x, x square minus x. This is between -1 to 1. These are given to you in any of the books or internet. Basis functions between -1 to 1. These are very well known actually. Or if not, you can do the derivation from my thing. Okay. So once you will change the limits, you will get here L1 factor, L1 by 2 here, here also L1 by 2. Rest of the thing you have the psi1 psi1, psi2 psi1, and psi3 psi1. Is that fine?
Yes, sir.
Now
Yes, sir.
just give me some time, at least 5 minutes or minutes. Then we want to calculate same thing for matrix number B matrix. B में you have derivatives. Rest of the things are same. Previously you have phi, now you have derivative. So जहाँ पे आपका function present होगा, वहीं पे आपका derivative भी present होगा, right? Correct or not?
Yes, sir.
Yes,
So
sir.
this is for B matrix. B matrix में you have d phi 1 upon dz and d phi 1 upon the dz. ये भी आपका change करके 0 to L का you will get the same thing 0 to L1. Now this you have changed the limits now, so this you will get now a factor here. This will become 2 by L1 because one factor will come for d phi upon the dz, other factor would become from d phi upon dz again. So you will get 2 times. So practically you will get a factor here 2 by L. Okay. ये आप चेंज करके के देखना कि ये do you get this or not? So this is now your the matrix means the elements now. For this you know the Gauss quadrature formula, right? How can we integrate this? Hello.
Yes, sir.
So now you have these are the Gauss points between -1 to 1. These are your values where you will calculate these functions root plus minus root 15 by 5, and the 0, and these are your bits. You 5 by 9, 8 by 9, 5 by 9. So you can calculate your C from here. So this is what your finite element formulation is. ये फिर complete program का part है actually. This is not the your part. How to calculate solvent and weight fractions. This is not the your part. Your calculation would end here because you are only interested just to calculate your concentration, right? Once you have the A matrix, once you have B matrix, your boundary condition matrix, you can solve them. So rest of the part is not your part, it is the my part, just to calculate the models and weight fractions, because once you know the concentration, so concentration would be calculated from here at any of the points. Any of the points, if you want to calculate concentration, you will multiply by U and phi j from 1 to 3, and you will calculate from here. Same thing for the C2 at every nodes. So हर node पे आपका concentration will come from here, because from the previous one you will get U1, U2, U3, U4, right? And from here you will get the concentration. Once you got concentration, the rest of the calculation is mine, just to calculate how the weight fractions and all this. It is not your part actually. So this is the again your not part, because this is the model which will give the diffusion coefficient and all this. So in your case you have to use your D something. So finally, let's say here you got this one, this you want, this is what the change of the limit here. Now this again you are calculating this the summation sign here from d phi upon dz at each of the derivatives. So let's say here I can tell you one more thing here what to do. This is just a element size, that how can you change the elements, because I said the that how can you change the elements and all this. So this is the functions which can be used just to generate the element within a given boundary. So let's say this your L is complete the boundary, and this from here you can generate the element size here. What is the difference, or you can say position of each of the element. So I just put here I minus 1 upon any to the power 2 multiplied by L. Any the number of the elements you want to choose. Let's say you want to choose 2, 3 and 4. Based on that you will get here what would be your position of R1. And the difference of R1, R2, you will get the element size. So this is what your finite element formulation was. So this is not your part. This is just to simulate and answer it. So my part is just your part is just to get these the matrices present and get your A matrix and B matrix completely. I can show you how the A or B matrix will look like. I think it's not there in this one. You have in the earlier presentation one. Okay.
Yes, sir. Yes, sir.
So you should also get your A matrix and B matrix. That's called your formulation. The rest of the part is your solution part. So by doing this, you can solve in that way with the formulation part. So at least you just generate your matrix A and B. Baki rest of the coding part is also not that much easy actually. Coding will also take a lot of thinking and part. First part is formulation itself. First you formulate your